We've talked quite a bit about logs and log equations, but let's just have a look at what the graph looks like. If you have an observation of this graph here, you'll notice that we've got f of x equals 2 to the x, and then we've got down here the log function y equals log base 2 of x, the corresponding log function. What you'll notice is that they're a reflection of each other. They reflect across the line y equals x. So in general, we can actually say that the graph of y equals log of a of x is the reflection of the graph y equals a to the power of x in the line y equals x. The graph of y equals log of a of x is the reflection, we flip it, of the graph y equals a to the x in the line y equals x. If we then compare some of the properties of these two separate graphs in general, you might be able to see some of these reflective properties going on. So we've got the graph y equals a to the x plus k, which is going to think about when a is greater than 1. And then we've got the graph y equals log base a of x take k. Okay, so there's more types of these graphs that we talked about before, because a doesn't just have to be greater than 1, but we're just going to think about that here. The domain of this graph is x, such that x is in R. You'll remember that the exponential function looks somewhat like this, where the asymptotic behaviour is happening over here when a is greater than 1. And so this function keeps on going forever and ever and ever. You might have an asymptote down here, but for all these x values along here, there will be a corresponding y value. The graph will exist for all the x values. So the domain is actually all x values. The range, however, is from k to infinity. Now what that k is, remember, is that's the value of the asymptote down here. This would be k, that the graph would never be able to cross. So that tells us that our asymptote is y equals k. Then we can say as x approaches negative infinity, y approaches k from above. That's what that positive means. So as x approaches negative infinity, y approaches k from above. And finally, can we consider the intercepts? So let's just consider the y-intercept. When x equals 0, y is going to equal a to the 0 plus k, which is going to be 1 plus k. And that's going to be your y-intercept always. So that's a bit of a review of that. What are the corresponding or similar properties of the log function? Well, our domain for the log function is actually this time limited. And we're going to think about that by remembering that actually we now have a vertical asymptote. You can see that up here. Here we have a horizontal asymptote that this graph never cuts, in this case x equals 0, but here we have a vertical asymptote where the graph never cuts, in this instant x equals 0, so y equals 0 there, x equals 0 there. So in general, the equation of our asymptote is always x equals k. Notice that it's in the form x take k up here. So when it's that take sign, it becomes x equals k. If it was a plus there, you'd have to do the negative. All right, so now we know that our domain is that, so that the graph can never cut this. So that means actually our domain is limited by the asymptote. All right, and so the values of the domain just go from x equals k, our asymptote, and then it goes all the way over to infinity. Our graph exists for all values of x greater than k because it cannot cross that asymptote there. So the domain, and you can write your domains in whatever way you like, but I'm going to write it as x such that k is less than x, which is less than infinity. Now you wouldn't have to write it like that. You could write it in the form k infinity like we did with the range over before. It really doesn't matter. All right. Now our range though in this case, because we've got a vertical asymptote happening, so we've got a vertical asymptote, it cuts it. Let's just draw a vertical asymptote there, and we're going to call that x equals k. This is another graph over here. You'll notice that the graph actually exists for all values of y. Okay, so if you think, or pick any random value of y on this axis and go across, there will be the graph existing. All right, so it can never cut here, but it has a value for all values of y. So the domain is the range is actually equal to y such that y is in R. That's what that sign means, y such that y is in R. Okay, now in this case, we're not going to talk about our y-intercept, we're actually going to talk about the x-intercept when y is equal to 0. So log a of x take k equals 0, because y equals 0. And then if we remember our index, our log laws, and the way the logarithm works, that actually means that x take k equals a to the 0, which means, I'm probably going to run out of room, that x take k equals 1. So in this case, x equals 1 plus k. All right, and that is going to be your x-intercept. So can you see that the behaviours are sort of the same, but they're just reflected for x instead of y? And then finally, we have what is our infinity behaviour. So this is, in this case, going to be as x approaches k from above, y approaches negative infinity. Let's have a look at the graph here. As x approaches k from above or from the right in this case, as x approaches k this way, y approaches negative infinity. X approaches k, y approaches negative infinity. Okay, x approaches k from the right, y approaches negative infinity down there. So let's do some examples. When you're doing these, remember to use your calculator, okay? Because all you need to do when you're drawing these is draw your asymptotes and draw your intercepts. Now, it's also really important that you read the question. So it says sketch the graph, but it also says give the maximum domain, the equation of the asymptotes, and the axis intercepts. So you can just write that all down here. Again, you can get this off the calculator, the axis intercepts off your calculator by just graphing these and then doing G-solve, and you'll be able to get these off your calculator. So let's just think about it though, because you might have to do it algebraically. So your maximum domain, and I'm going to do, of course, the graph number 1. I'm going to do number 1 down here, and I'll do number 2 over here. So let's think about the maximum domain for both of those. Maximal domain, I'm just going to put maximal D. All right, so we've got f of x equals log 2 of x plus 2. Now, first thing we've got to think, is that in the form x take k? And no, it's not, because it's x plus a number. So it might help you to actually rewrite this one as log base 2 of x take negative 2. All right? Because then that is in the form x take k, and so you can just read off things. So the 3 things we've been asked is the asymptote, and then the intercepts, and y-intercept, and over here the asymptote and the x-intercept and the y-intercept. Now let's just go with the asymptotes first, because they're really easy to read off. Remember, this is a log function, so it's x equals k, so your asymptote is x equals negative 2. Over here, what's your asymptote? Well, this is for the function log of 2 of 3x. Now, there's no k value, you see. If there's no k value, it actually means that k is equal to 0. So, therefore, your asymptotes is just that x equals 0. Easy. Now, once we've got our asymptotes, it's really easy to work out our domain. But we did write it up here. Our domain is just going to be negative 2 to infinity. That makes sense because we've got an x asymptote, a vertical asymptote. So the graph can never cut that line that goes through x equals negative 2. So it's got to be bigger than that. So our maximum domain is negative 2. Over here, our maximum domain is going to be 0 to infinity. Again, k to infinity. Then we've got to think about our x-intercept and our y-intercept. Well, in this case, you're not going to have a y-intercept because you've got a line at x equals 0. So nothing is going to cut that line. So you're not going to have a y-intercept. You will have an x-intercept though. If we go, so log base 2 of 3x equals 0, that means therefore that 3x equals 2 to the 0, and therefore 3x equals 1 equals 1, therefore x equals 1 over 3. Okay, so that's your x-intercept. If you're ever asked to give the x-intercept, make sure you write it as a coordinate. Alright, over here, can we get our x-intercept? It's log base 2 of x plus 2 equals 0. So therefore, x plus 2 equals 2 to the 0. X plus 2 must therefore equal 1. And so x is going to equal negative 1. What about our y-intercept? Well, that's when x equals 0. So in this case, it's going to be log base 2 of x plus k, where k is 2, is going to equal, what does that actually equal? Okay, that's what we're trying to work out, because we've got y equals log base 2 of 2, well therefore that's always going to equal 1, okay, when you've got the log base 2 of the same number. Alright, so we've got our x-intercept and we've got our y-intercept and we've got an asymptote. It's a bit messy, let's just put a line down there. So I'm just going to quickly sketch in a graph, and it says a sketch. When you've got a sketch, make sure you do the right scale though, and draw straight lines for your axes. That wasn't very straight. Never mind. So there we go. Now it's straight. Just put the rest on a diagonal. So let's draw in the asymptote. X equals negative 2. Make sure you draw it in. Dotted line. Arrow up the top. Arrow down the bottom. Label it as x equals negative 2. Very important to do that. Then I just put some lines here so I know what your scale is. So that's going to be negative 1 and that's going to be 1. Also put lines here so you know what your scale is here. That's going to be 1 and that's going to be negative 1. Alright, your y-intercept we said was 1, so it's going to cut there, and your x-intercept is negative 1. So then we just draw those dots and you're done. All done, you just drew your first log graph. Not that hard, is it? Alright, over here, let's draw this one. So this is log base 2 of 3x. Okay, so again, draw in my y-axis and my x-axis. Okay, now it's always a bit hard to draw in the asymptotes, but you can draw a dotted line on top of a thing. If you do it dark enough, you can show that it's a dotted line and just extend it over the edges a bit and put that x equals 0 and label that. Then we don't have a y-intercept because of that, but we do have our x-intercept there as a third. Again, I just put a scale in, so I put negative a third over there. Just to put my scale, and then that's all I've got because I don't actually have a y-intercept, so I can just go boom and boom, and that's all you need for your sketch of your log function. Make sure it's clear that you're never going to touch this, alright? And you want to put arrows on the top. Make sure it's clear that you're never going to touch the asymptote. So if you're drawing one of these graphs and it looks like it's going to cut, that's no good. Alright, make sure you don't. Okay, well have a practice doing that. I hope that makes sense. It's a little bit messy, but enjoy.